Welcome to Study Loop.
Welcome to a new problem. This time we have a railroad handcar, so it's moving straight. We have a railroad handcar, and it happens to be moving straight. These trucks are frictionless. So we have frictionless trucks with negligible air resistance, and there are a bunch of cases happening here. The total mass of the car. Um, Mass of the car happens to be 200 kilograms, and it's traveling eastward this way. So it's traveling eastward with the velocity, which we call the initial velocity of the car, happens to be 5 meters per second. So we'll say a positive 5 meters per second. Remember, we can have a y-axis, positive y-axis, and then positive x-axis going towards the right. Um, and so it's traveling in the x direction. The and then a couple of things happening. The car has contents inside of it. Okay, so the we can think of this as a block. Okay, we can think of it as a block, and the block happens to be 25 kilograms. There's a block inside of it which happens to be 25 kilograms. So the car, the total, this is MC, this is the total mass of the car, um, uh, and the block itself inside. So before anything happens in part A, so this is what we're given. In part A, we want to find what's going to happen. So think about this as being a plan view. So this is a plan view, and the car is moving that way. So what's going to happen if you um, throw the mass, the 25 kilogram mass, sideways? Okay, so remember the car is moving that way, eastward. So we want to find the final velocity, v final, of the car, um, if you throw this block sideways. And then in part B, we want to find out the uh, so this one, you're throwing the block with a velocity of two. In this case, they're saying um, has a velocity of 2 meters per second. Okay, so throwing outside with a velocity of so you have a 25 kilogram mass, and it's thrown sideways with a velocity of magnitude 2 meters per second relative to the car's initial velocity. So 2 meters per second relative to 5 meters per second. That was the car's initial velocity. So that's what's happening in this case. And then in part B, we have a case where it's going to be thrown backwards. So the mass, the MB, which is 25 kilograms, it's thrown backwards as the car still moves eastwards, and we want to find the final velocity of the car in this case also. And then in part C, we have a different scenario where the 25 kilogram mass is thrown into the car. So it's thrown inside of the car, um, and relative to the ground in the opposite direction to the initial velocity. So I think we have to change how it's thrown, because they're saying it's thrown relative to the car in the opposite direction to the car's velocity. So the car is traveling this way. The car is traveling eastward to the right, but the object is thrown that way inside of the car, um, from that position. So we're gonna start solving part A in the next section, in the next page. So again, just going back, this is what we want to find out, and this is what we're given. So we're given that, and we want to find out that. So in the second part, we we're gonna use the law of conservation of momentum, law of conservation of momentum. And here we're saying, the momentum before throwing the mass sideways is equal to the momentum after throwing the mass sideways. The momentum is the same. And so before throwing, we have the total mass of the car, and that's the mass. Maybe we need to change this. This mass of the car has to be so MC is the mass of the car plus the block. So we want to do it that way, the mass of the car and the block. That's going to make our life easier. So the mass of the car plus the block times the initial velocity of the car and the block. We're going to call it that way. So we're putting them together. This one is initial velocity, we should say, of the car and the block together. That's the initial. It's 5 meters per second. So that one times the initial velocity of the car and the block equals to, once you throw the block outside, it's by itself. And it has its final velocity of the block. And, the car also now is by itself. The car is by itself because now you've taken out the block inside, and the car also has its final velocity by itself. So our target is to compute the final velocity of the car. So VC final equals to MC plus B. So this is just purely algebra, the initial velocity and the initial masses. This one is going to go to the left. The momentum of the block after you throw it out, it's going to go to the left, becomes a minus VB final, all of the mass of the car. And so, if we plug in the numbers, we get, we have to do that on the next page. So going on to the next page, we get I have to go back and check. So mass of car and mass of block, that was 200 kilograms. So 200 kilograms times velocity of car and block, that's the initial 5 meters per second, or 5.0 meters per second. And then when we go back, we have a minus there. Mass of block is 25 kilograms. And remember, it's thrown, when it's thrown sideways, it doesn't have any velocity relative to the ground. Okay, so we only have in the x direction. There's no conservation in the y direction, so no momentum conservation in the y because of the force provided by the truck, against the side motion of the uh, handcar. So that's kind of what's happening. The block thrown outside, therefore, in the x direction, momentum is conserved. It's going to have a velocity of 5 meters per second. And then we have to divide by, if you go back, you see the total or the mass of the car. Remember the mass of, just as a side note, the mass of the car plus the block happened to be 200 kilograms, but the mass of the car equals to the mass of the car plus the block minus the mass of the block, and that gives us 175 kilograms. So when you plug in those numbers, you get that the final velocity of the car happens to be 5 meters per second. So it's like it never changes, and that makes sense. You're throwing it to the side. There's no impact on the forward motion in the x direction. In the second part of the problem, we want to find what's going to happen when you throw, as you can recall, when you throw the block backwards. So now we want to see what's going to happen. Now you're throwing the block backwards, the car is moving forward, and so we're interested in finding out the momentum in this case. So the initial, again, momentum is going to be conserved. Initial momentum equals to final momentum. So mass of car plus block times initial velocity of car plus block equals to the mass of the block times the final velocity of the block plus the mass of the car times the final velocity of the car. So something special happens right here. The car has an initial velocity relative to the ground, and then the the block itself, the block itself, the block also has a velocity. The block also has a we want to say the final velocity of the block relative to the ground. So that's what we want to find out. So the final velocity of the block relative to the ground equals to the final velocity. Actually, we should do the initial here, not the final. These are relative velocities we're looking at, and so we're saying the initial the velocity of the block, the initial velocity of the block relative to the ground, is gonna affect the velocity, this initial velocity of the the initial velocity of the car relative to the ground is going to affect the initial velocity of the block relative to the ground. So this is V initial relative to the car plus the velocity of the car relative to the ground. Yes, that's what it is. So this is the velocity of the block relative to the ground is -5 meters per second, plus the velocity of the car relative to the ground is +5 meters per second, and you can see that the velocity of the block relative to the ground will be 0. This is the final velocity. This is the final velocity. So I think we should say This should be final right here, final velocity of the block. We have to simplify that, not initial. This is final because it's being thrown outside. So when it's thrown outside, its velocity is dependent on its relative velocity to the car, and then the car's velocity to the ground. So that's going to be zero. That just means that the final velocity of the block right here will be zero. So in computing the final velocity of the car, we get to use mc plus b, vc plus bi. We're just saying that's the initial momentum, this one, divided by this mc. So you're simplifying, and then we plug in the numbers. When we plug in the numbers, we get this is mass is 200 kilograms, and then times that initial velocity, 5.0 meters per second, and then we want to divide that by the mass of the car, 175 kilograms. Remember, we got 175 because of this statement right here. So you're subtracting, you're taking the 200 kilograms minus the 25 kilograms after the block is thrown out, and that gives you 175 kilograms. So that's the number we're using here. And so the final velocity of the car becomes, once we simplify it, it's about 5.71 meters per second. 5.71 meters per second. That's the final velocity of the block. On the next page, we want to determine what's going to happen. As you can recall from our diagrams, this time the block is being thrown inside. So it's kind of like this. You have the car moving that way, and then the block is thrown inside that way. So we want to find this final velocity of the car when that scenario happens. Again, we're using law of conservation of momentum. And in this case, we're going to say the initial momentum equals to the final momentum. The initial momentum is when they're separate from each other. I think one of the pieces of information that we get is the velocity of at which the block is thrown inside. So it's 6 meters per second. And when right here, when the block is thrown inside, the final velocity of the block, the initial velocity of the block, is negative 6.0 meters per second because it's moving in the opposite direction as the car. And so we're going to use that. Before anything happens, we have the mass of the car and the initial velocity of the car plus the mass of the block and the initial velocity of the block, that being equal to both of them both of them together. So remember, the block is going to be thrown inside the car. It's going to be thrown inside the car. And so in this case, we're saying before you throw it, what's the momentum, what's the total momentum in that case. So we have mc plus mb, and the velocity itself, and the velocity, the final velocity, because they're going to be together. When you throw them together, they're going to be together. So this is the final velocity of the car. And so mcvci, the initial momentum of the system before you throw the block inside, equals to the final momentum of the system after you throw the block inside. So that's going to help us get the final velocity of the car, which is mcvci plus mb vbi. And then you want to divide that by their combined masses. This is the combined masses of the two of them. You combine them. And so we have mc, which is the mass of the car, um, two 200. This is gonna be um, this is gonna be 200. Yes. So this is gonna be 200 times 5. So this is 200 kilograms uh, times 5 meters per second, plus mass of block is 25 kilograms times um, -6 meters per second. Remember, it's going opposite. Okay, and then we want to divide that all of that by by the combined mass, 200 kilograms plus 25 kilograms. So that's what's going on in this problem. Uh, the So 25 kilograms, and then when you solve that, you're gonna get 3.78 meters per second. That's the final velocity of the car uh, in this scenario. Hope you enjoyed the problem. Again, this was about three different scenarios. In one case, a block is thrown sideways. In another case, it's thrown to the left, backwards. In the final case, it's thrown inside. Sideways, you can see there's really no impact on the final velocity because you're computing velocity relative to x, and so when it's thrown sideways you still end up having the same velocity because everything is happening in the y. And then also when it's thrown in the second case, you can see it's thrown backwards. So when it's thrown backwards, what's going to happen is that there's going to be an impact on the velocity of x itself. There's a relative velocity happening here, and that's the velocity of the block relative to the ground will be 0. And because it's 0, the final momentum of the block is 0, and that gives you the final velocity of the car is 5.71. And then finally, you have a case where it's thrown inside. Initial contents were 200 kilograms, and then you're adding another 25 kilograms, but the velocity of the block is moving in the negative direction. That's why we have -6 there. You simplify and find that the velocity of the car is positive 3.78, still moving forward. Hope you enjoyed the problem. Feel free to ask any questions, and have a wonderful day. Okay, thanks. Bye.